example. So in the first, we try to discuss about genetic algorithm steps. It contains about 10 steps, which is here 10 steps. Start by the first, initialize, try to represent the problem by variable domains, by initialize the chromosomes, what is the chromosome size, what is the chromosomes contains, and also initialize the size of random selection, the population, by numbers, maybe 10, 100, it's a number of chromosomes, and then also initialize the probability crossover and also the mutation probability PM. Here the values for crossover probability between 0 and 1, also for mutation between 0 and 1. Then after initialization all the parameters, then we'll step number 2, define the fitness function, which is the problem. You want to get what is the fitness function here. You want to select like okay, if I want to write something, cannot write anything, it's okay. So fitness functions, which is to measure the performance or try to like the speed, or maybe you have functions f of x equal x squared plus something. That is the fitness function. Then also you have to identify whether you want to find the maximum or minimum values. Then step number 3, after you initialize the parameter of the genetic algorithms, the fitness functions, now you create random solutions. Random solution, how many solutions? Depends on the size of population, the size of population. We can see an example later. And then step 4, after initialize randomly solutions, then try to evaluate each solution individually to calculate the fitness functions. The fitness functions based on the fitness functions identified here in step 2, like f of x, x squared plus 15x or something. So we can just evaluate individually each functions or each chromosome by apply and then get the results. After that, selection pair. This is called step number 5, how to select the parents or to select the pairs that can use to generate new solutions. So here in the selection, we can use different approach to use for a selection, maybe by random or by using the roulets or by using tournament, means select the highest values to do whether crossover in step 6 and mutation. So in the step here, step 5, just to select the parents that will go through in step 6 to do crossover or mutation. So in step 6, we can do whether crossover or mutation. With crossover, we have 2 types of crossover, whether 1-point crossover or 2 points crossover. And we have also different type of crossovers, such as if we have 1 point or 2 points, but depends on the chromosome features, whether it's just numbers or alphabets. So we have to consider this. We can have your scrambling crossover or any type of crossover. Mutation, we can just select genes or number of one gene or maybe 2 genes, and then try to change their values by whether plus or minus values, or by changing swap between 2 genes. That also can be mutation. Number 7, after place and created the offspring, mean the new generation, and then have to be this one in the new population. So we have the original population n, maybe 10. Then here we have to create the new generation and store in that the new population. And then here number 8, repeat step 5 until the size of the new population. So we can repeat from step 5, selection, to crossover, mutation, and store until all the new population store with all solutions. Then we go to step number 9, which is replace initial parents chromosome population with the new offspring population. Here in the change, there are different approaches. If you want to replace, some of them they just replace if they find the new solution is better than the previous solutions in the new population, better than the previous solutions, so it can be replaced. Some of them they just replace with however it is worst or best, they just replace. Some no, they have to do some comparing between the solution and just replace the worst solutions. And then step 10, so again here this one will be repeated. All the steps will be repeated from step 4 until, because step 4, which is start from calculate the fitness here for each individual, because the new solutions need to be calculated. Then this one, selection pair, again new population size, then this one again repeated until satisfy with the exit criteria or termination criterions, which is maybe based on loop, or based if you find your target, you define your target. I want to reach to the value 10 maybe. Then you keep try until maybe you find 10. You can stop, or maybe you can put another condition, which is you have a loop, maybe 1000 times, 100 times. You try until you reach that number. Even you don't reach to your target, but you can stop there. So thank you. We introduce the steps of genetic algorithm. Now we come and explain each stage. We come again for genetic algorithms. We start here by genetic algorithms start by initialization, or by creating the chromosomes. So the chromosomes or population can be a bit string in the chromosome here, or can be a real number in the chromosome, or can be a primogen of elements. So elements can be in a sequence, or in a sequence you have elements from A1 to A15. So each chromosome have a different sequence, but you don't have any value out of these values. Okay, or maybe you have a list of rules. You have rule number 1 until rule number 23, like in fuzzy logic. You have rules, and then you keep changing the rule sequence, changing the rules selection, and that can be as a chromosomes. Okay, so also program elements like genetic programming elements. So any data structure, it can be used as a chromosome. So parent selection. In the parent selection, as I said, based on the fitness function. So the fitness function will be determined with a possible solution get passed into multiply and mute into the next generation of solutions. So usually by analyzing the genes, which hold some data about a particular solution to be a problem you are trying to solve. So the fitness function will look at the genes and make some qualitative assessment, returning a fitness value for the solutions. Rest of genetic algorithms will discard any solution with a poor, as I said. If you have a poor solutions, because we use a fitness function or objective functions, those solutions in the population, if they have a poor solution, then maybe can be neglected and keep the best solutions. In short, the goal of fitness function is to provide a meaningful, measurable, and comparable values of the given set of genes or a given set of chromosomes. You have a chromosomes, maybe if you have a population size by 5 populations, you have 5 solutions. How to compare between all these 5 solutions? Of course, using the fitness function. So then, how to select the best or survivor parents? There are different strategies. Always keep the best if one, or delete the worst. Okay, or by selection the parents of the next generation of candidate solution by using or methods roulette or tournament. Who have maybe roulette, you put all solutions in a roulette, then you randomly run that roulette. If you have, let's say, programming, you put your solution number 1, solution number 2, solution number 3, and then you select random. You keep random, and maybe you put high percentage for each solution. You put percentage for each solution, then maybe it will have a high percentage to be selected. Or tournament mean you select the best, who has the best fitness functions. It can be selected. Let's say, for example, you have here 6 solutions. x1 and x2, x3, x4, x5, and x6. If you apply the roulettes here, the roulettes, so solution number one have 16 percentage, so to be selected. X2 have 20 percentage to be selected. This one is x2 and x1, and x3 have a very low percentage, mean have a very low percentage to be selected, as well as x4, but x5 have high value or high percentage to be selected, as well as solution number 6. So in the tournament, also like using binary tournaments, two individuals are randomly choosing. Then the fitter of these two selection will be as apparent. So then probabilistic binary tournaments, like in this variant, two individuals are chosen at random, and then better of two individuals is selected with the fixed probability. So it can be based on the probability between 0.5 to 1. So maybe we can use tournament also, or roulette. Larger tournaments means n individuals are randomly chosen. The fitness one is selection. Here there is a large or binary or probabilistic. Large mean you select many solutions, then you select the fittest one, mean the best one, using the fitness function. Then if you